Hey guys, welcome to my channel and I'm back again with another really interesting coding interview question video. Today we are going to solve another Leetcode premium question number 1099, two sum less than k. So yes, we have solved two sum problem, we have solved three sum problem also, which is also similar, but this is a little bit tricky. It is called as two sum less than k. And because we have the premium, so we can also look at the companies where this question has been asked, and you can see that this has been asked almost 3 times in Amazon within the last 6 months. So definitely an important question. Let's go look into the problem statement now. So basically guys, we are given an array nums of integers and we are given another integer k. We have to return the maximum sum such that there exists an I which is less than j with the nums I plus nums j equals to sum, and sum is less than k. If there is no I comma j exists that satisfy the equation, return -1. So what it is trying to say is that we just have to find out two numbers whose sum is actually less than k. We have to find out two numbers whose maximum sum is less than k. If we can find any such two numbers whose sum is less than k, then it's fine. But if not, then we have to return -1. You can see here the k value is 60. So we can use 34 and 24. So if we take 34 and 24, we get a maximum two sum. So maximum sum out of all the combinations of two numbers, and this maximum sum is less than 60. Okay. So you can see that with 34 plus 24, you get a maximum sum of 58, and that is what we are outputting. So obviously guys, you can have 23 and 1 also, and 23 and 1 is also less than k, but this is not the maximum sum which is less than k. So that's why we are returning 58, which is the maximum possible sum we can obtain by adding two numbers from this array. And then you can see there is another example here where we have these numbers 10, 20, 30, and the k is 15. So you can see that there is no two number combinations here which can actually lead to a sum which is less than k. So if you do 10 plus 20 is 30, if you do 20 plus 30 is 50, if you do 30 plus 10 it's 40, right? So there is no two number combination. That is why the output is -1. Now let's look at the constraint. The constraint here is that the length of the number array goes from 1 to 100. The value of the array goes from 1 to 1000, and the k value goes from 1 to 2000. Okay. So now that we know about the problem statement guys, let's look into the solution approach. So first thing first guys, if you want to solve this problem with a brute force approach, so that is pretty straightforward guys. So we can just iterate over the nums array. So we can have I go from 0 to n, and then we can go j I plus 1 until n, right? So we can have two loops going, and what we can do is we can just take the ith number and we can try to add it up with all the numbers which are which are next in the line. So let's say I take 34, I add it to 23, I add it to 1, I also add it to 24, 75, 33, 54, 8, right? So I basically take this number and I try to add this number to every other number, right? But what will happen in that case is that at every single point in this second inner array, we will just find out our maximum sum, which is less than k. And finally, after both these loops are done, we will return the maximum sum, right? Right. So what we are trying to do here is guys, we are just running two loops. So if we take this brute force approach, you can see that this is going to cost us order of n to the power 2 time complexity. Why? Because we are running two loops, right? So even though this approach is possible, and you can see in the constraints that the numbers which we have in the array is less than 100, so it should be okay in this case, but still we want to have the most optimized solution. So we can't use the brute force approach. Okay, this is the brute force approach, that you just run two loops, one starting from 0 to n, other starting from I plus 1 to n, and you just calculate the max sum, which will be what? I plus j and ith value plus jth value, and then finally we will check if max sum is less than k. Okay. or I can say here it's nums I and nums j. Okay, and if the maximum sum is less than k, you will keep the maximum, you will update the maximum sum, otherwise you are going to skip it to the next combination. Now, because we don't want to use the brute force approach, there is another approach that we can use, and that is called as the two-pointer approach. So in the two-pointer approach, what we are going to do, we are going to have a low pointer and we are going to have a high pointer. So low pointer, or you can say a left pointer and a right pointer, right? So left pointer will point to 0 and the right pointer is going to point to the nth value, right? So what we are going to do, n minus 1, we are going to take the elements starting from here and starting from the end. But this approach will only work if we have the array sorted, because what we are going to want to do is we are going to start adding the lowest element and the highest element, right? And if that sum of lowest element plus highest elements is less than k, in that case we will increment the lower element to become a little bit higher. So basically we will increment the lower pointer to +1 and we will start adding the next bigger element. And if the sum is actually greater than k, then we will actually decrease the right pointer so that we now add a smaller element into our sum. And while we continue to do that, at the end of this iteration, we will eventually find out the maximum sum that we can achieve with the two number combination. So first thing first, even before declaring these arrays, I can say you just sort the nums array. Now your lower element or your left element is actually pointing to the lowest element in the array, which is at the 0th position, and the right pointer is pointing at the highest element in the array, which is at n minus 1th position. Okay, so now what we are going to do is we are going to just run a while loop where your left element is or left pointer is less than your right pointer, and we will just do a sum of left element plus right element, right? And here we will just check if this sum is less than k. In that case, what we are going to do, we will increment the left pointer, otherwise we will decrement the right pointer. And at every single step in this, we will keep updating the max sum to the maximum of sum and max sum. Okay, and when this while loop is going to be over, we will just simply return my max sum result, right? Now this approach is much better than the previous approach because there are no two loops here. But what will be the time complexity of this particular approach? The time complexity of this particular approach actually depends also on the sorting algorithm. So if we are sorting an algorithm and we are using some optimized sort, then probably you will have n log n as the time complexity for your sorting, right? And this while loop is definitely running through all the elements, right? Let's say half of the elements, so you can make it order of n by 2, but because this is big O notation, we are going to keep it order of n. So eventually your time complexity will be order of n log n. Okay, or you can say that it is going to be a linear multiplied by a logarithmic time complexity. So if your array is sorted here, you might achieve a linear time complexity with this approach, and that's called as a two-pointer approach. Okay, now that we know a little bit of an optimized approach, it is time for me to start implementing that for you. So let me just write the code for that as well. So here is the code. Let me go through that. So first thing what we have done is we have sorted the elements. Then we have initialized I to 0 and j to the length of nums minus 1. So in the pseudocode I was writing L and R, which is left pointer and right pointer, but this is similar to that. You can consider I as the left pointer or the pointer at the lowest element, and j as the right pointer which is at the highest element. And my result is obviously minus 1, because if nothing is found, we will return minus 1. We will run a while loop where I is less than j. The value is going to be the addition of the ith element and the jth element, and then we are just printing it for debugging. But if your sum or your value is greater than equals to k, that means you have to decrement your right pointer, and in our case j is my right pointer, so j minus equals to 1. Otherwise, if the value is actually less than k, then that means that this value could be my actual result. So here I will check if this value is greater than my result or not. If this is greater than my result, then the result will becomes equals to val. Or you can even call a max function here, and you can assign the value to the result variable. And finally, in this else condition, because the value is less than k, it is time that we can try to increment my left pointer. So I is my left pointer, and I am doing I plus equals to 1, and finally I will return my result. Let's run this code, guys. Let's see if this works for our problem statement. You can see that it accepts all the test cases, right? And it works, right? But there is another sort of similar solution that we can do with this, and because we are already sorting the elements, right? So let's say I'm already sorting the elements and I'm using 2-pointer approach, right? But because we are sorting the element, we can also do a binary search on my array to actually find out the element that we want to add. Okay, and how we can do that? So basically, guys, we can see that we have, let's go to this description below. So we can see that in this description we have a sorted array. So instead of moving 2 pointers towards the target, we can actually iterate through each element, and then we can actually do a binary search for a complement value. So let's say you are at ith position, right? You are at ith position. So let's say you have nums I value, and what you need to find out in the array is actually k minus nums I value. If you are able to find the k minus nums I value in your binary search array, then it means that you have actually found a perfect sum which leads to k. But if you don't find this k value, k minus nums I value also, with binary search you will actually find the next best value in your array, right? And that can also lead you to your approach. Okay, however, this is a little bit more like if you are in a coding interview, this approach might not come to you if you have not actually practiced it. So that's why it is just good to know. But if you cannot come up with this in your interview and you are doing it with the 2-pointer approach, this is good enough as well. What I'm gonna do is I'm gonna actually write the code for that, and then we will go through that line by line. So you can see that my result variable on my answer variable is initialized to -1. We are doing the sorting of the nums array, and then we are going through the nums array from I to until the length of the nums. And in Python, for binary search, we can use a bisect underscore left function. And what this function is actually doing, it is actually trying to find out for every ith element, it's trying to find out in the nums array k minus nums I. Okay, so what it is going to do is it is going to start from I plus 1, that because obviously ith element cannot be k minus nums I, right? So it will start from I plus 1 in the array, and it will go through all the nums array, do a binary search, and finally it will come up with the position where k minus nums I value is there, or the next closest value of k minus nums I is there. We will just do the -1 here because our indexes start from 0, and now here we will just check if j is greater than I or not. So if j is greater than I, it means that if j is greater than I, then it means that this particular value is something we can, okay, yeah, so sorry about that. Actually if j is greater than I, we are giving that value because it says that there exists an I less than j. Basically what we can do here is that I cannot be equals to j, right? So j has to be greater than I. If that is the case, then it means that we have found our result, and we can just check if the num_psi plus num_stay value is greater than my current answer or not. If it is greater, then the answer will become that. If this is not greater, then the answer will remain the same, and finally we can return the answer. Okay, now let's run this code, guys. Let's see if this works for our solution. And you can see it gets accepted. Let's submit this code as well. There you go. But again, guys, this approach takes the same amount of time complexity, so it is also n log n, because we are using a sorting algorithm of n log n, and then we are again going through a while a for loop which is going to take n, and the binary search takes n log n, right? So this is actually going to be order of n log n, n for the loop and log n for the binary search. Okay, so this approach is also going to be order of n log n, and the two-pointer approach that I just told you was also n log n. So that's why I'm telling you that if you can come up with any of these approaches, it is going to be valid for your interview question. So yeah, thank you so much for watching, guys. I hope you guys liked this video, and I hope you learned something from it. If this video helped you in any way, then please do not forget to like this video and share this video with your friends. If you have any questions, comments, suggestions, feedback for me, please do write down in the comment section below. I would be really happy to address them. And in the end, guys, if you have not yet subscribed to my channel, please do subscribe and hit the bell icon for future notifications of more such programming and coding related videos. I'll see you guys in the next video, guys. Until then, take care and bye bye.